technology, we are living in incredibly exciting times. We have sort of understood the human genome. There's an area called synthetic biology, which is where we can actually take artificial DNA, put it into a living cell, and create products. And in my area of astrophysics, we are discovering planets going around other stars. We call them exoplanets. And so far we've discovered about 2,000 of them, and more are coming onto our screens.
We have a cluster here to be proud of in our high vacuum technology, and it's something that Hastings should be known for, not just in the region, but we should be known about it across the country, and we should be known about it worldwide. And I think it's particularly fitting that we're here in Sussex Coast College that has got the first high vacuum technology courses being offered.
What we're basically doing is we are trapping atoms with laser cooling in small vacuum chambers. So we can use these trapped atoms to do various techniques. So for example, one thing we can do is build a very, very precise atomic clock. The future ideas of what we're hoping to achieve is basically, instead of all of this, basically we'll just have the entire system shrunk here, 3D printed, and then all into basically a very small compact product. You could hopefully in the near 5 to 10 years actually just buy a very small portable clock.
Hastings as a company are specialists in motion, both rotary and linear systems. We do all sorts of work for anything from defence systems. We do a lot of work for simulation for F1 companies, etc.
I'm Trevor Mayers. I come from a company called the European Synchrotron Radiation Facility. We're based in Grenoble in France, down here. Basically we're here as a major customer of UHV equipment. We have something like 2 kilometres in length of UHV equipment. We really appreciate this conference because we're able to meet specialists in this field.
You know graphite probably from pencils. You can write on paper with graphite, and you can also make graphene with graphite. And what is graphene? Well, graphene is just one single layer of carbon atoms that you can actually peel from a graphite crystal. And so it's shown here. This is a piece of natural graphite which you can mine. And if you are very careful, you can actually peel a sheet of graphene from such a crystal, which is just 1 atom thick.
Just as you have a vacuum cluster here in Hastings, we have a cryogenics cluster, which for the most part is Oxfordshire based. And I currently work at the Cullen Centre for Fusion Energy, but as Maggie said this morning, she's a space scientist. I'm a cryogenics engineer and practice.
We manufacture high-quality vacuum viewports. The lenses in the viewports are ranging different materials, planar optics, and the specialist part of what we're about is actually the hermetic sealed, the way we braze these different materials together. This is another X-ray anode that we manufacture, but on some of them we actually put a CVD diamond on the ends. And we've been doing a lot of work over the last couple of years with the University of Surrey, ensuring that we get very, very good adhesion with our coatings to get that thermal conduction.
And we specialise in manipulation and motion in ultra-high vacuum systems. So our products such as this, for example, are used to transfer samples within ultra-high vacuum. So the sample goes on the end there, and you can move within the vacuum system and then lower into a deposition stage or an analytical stage and then retract.
But these can do many different things, but in the vacuum industry generally 2 types of measurements. One is to measure the thickness of thin films, and the second is to look at plasma displays, often used in conjunction with vacuum equipment.
Ownership of copyright is the biggest problem that we come up against every single day. Usually it is the first author or creator that owns it. So I wrote that novel, therefore I own it. However, if I am employed and I create something as part of my ordinary course of employment, I employer it. So for me, my job is to talk about IP, creatively science and help me do that, therefore The government owns these sites.
The Biotechnology and Biological Science Research Council, you've got the Engineering and Physical Science Research Council, that gets £800 million a year. These are all agencies sponsored by government to support growth through research and development that all offer some sort of funding. And it's worth having a look through those to see what might be relevant for you.
We specialise in leak detection technology, calibration equipment, and we also do a wide range of vacuum subcontract services and products. So yeah, the calibration traceability and manufacture of calibration equipment is our speciality.
We're specialists in vacuum manipulation and chamber manufacturing. Very basic X and Y stage with a Z travel as well. Moving on to the larger bore items with a very smooth Z motion with an extra large bore.
What we are doing is importing Japanese vacuum related product into Europe, and I've got is the rapid heating technology using IR lamp, and also we have got the vacuum gauge which can be used in the corrosive gas environment, and also we got the dry vacuum pumps.
And if we look at examples of where we see that, it's essentially ubiquitous, it's everywhere. So illuminations and displays, the display we have here, optical communications of course, how we communicate, how we store data, how we retrieve data, manufacturing, so lasers and so on for that. In medicine it's becoming more important, and I'll give a few examples of that. And more generally in sensing, okay? And it turns out that essentially doing things in the optical domain is one of the most sensitive ways you can measure something. Okay, so it's an important field. There's now a $10 million prize for the first group to develop the tricorder. And the tricorder, the idea is to have a handheld device that has various sensors in it that can pick up 10 different types of disease or illness. Okay, and if you can do that with a handheld device, you win the X prize.
Bring something slightly different to the table compared to a lot of the other bigger corporations that are our competitors. Is that we can react quick because we're quite small. We do very, very high quality vessels, from design to manufacture, from testing to all the way through to end user. We're here today supporting Hastings. I think Hastings is it's got a big tech sort of industry based in Hastings, which some people don't know about, especially local people.
It's good for East Sussex, it's good for Hastings. There's a cluster in the area of companies that have these high technology skills, and on that basis it's really good, and it brings everyone together. People interact, the companies work with each other and interact with each other, and it's just a fabulous thing.
I'm sure today, being the second exhibition and conference that we've run here in Hastings for Tech 66, further grows and enhances the reputation of the region, and we're looking forward to taking that internationally, especially to the Middle East in spring 2015.
I think the important thing is that this industry of advanced manufacturing, photoelectronics and high vacuum is beginning to give this part of East Sussex an identity that it's never had before.
I know science and engineers, and we get just as excited and probably even more excited than many people I know. And so what we need to do is we need to get out there and share that passion with everybody. Because we need to do it for the next generation. Because we are doing wonderful work, but we need the next generation to come in, take over, and continue that work. Thank you very much for listening.